All right, we're going to start on our third lesson of week 1. So if you can find your notes, 8-7, factoring special cases. So this lesson is going to be easier than yesterday's lesson. First, if you guys could just go ahead and do your arrow method or FOIL, whatever method you like, and go ahead and figure out the answer to these three when we multiply. All right, so check over your answers and see how you guys did. Notice the top two, we had the middle terms cancel out and we're just left with x squared minus 9 for this one, 4x squared minus 49 here, x squared minus 6x plus 9, and 4x squared plus 28x plus 49. So now when we factor these, we're going to notice that we're going to get special answers. So for 9x squared, like we learned yesterday, that could be 9x times x, or it could be 3x times 3x. We're going to try just the 3x and 3x because I think all of these are going to be similar to what we just did, where the both binomials are really similar to each other. And again, for 4, we could do 1 times 4, or we could do 2 times 2. Let's try 2 times 2. Let's go ahead and check our answer. So remember, it's first, outside, inside, last. First are these two, and yes, they're 9x squared. Outside, inside, outside, these two multiply to 6x, and these two are multiplied to 6x. 6x and 6x, yes, is 12x, and we know 2 times 2 is 4, so we have the correct answer. Okay, here we'd have to be a little bit careful because of our 8 in the middle is negative. So for 16, I know lots of things multiply to 16, but for today we're going to try 4 times 4. And what signs do we need so that they add up to negative 8? And they multiply to positive 16. And the answer is they're both negative. You can check this on a chart and make sure. Okay, notice here we only have a binomial. These are going to end up being similar to the first two problems we did. So we still have x times x is 64, or x times x is x squared. And we know 64 is 8 times 8. Well, how do you get to a negative 64? You need to have a positive and a negative. And that's exactly what we want to happen because we want these to cancel. Sometimes kids make this mistake. They remember it's x times x, and they remember there's a positive and a negative, but they'll pick something else that multiplies the 64 like 2 and 32. Well, that's not going to work because when you do the outside inside, it's going to end up being x squared minus 32x plus 2x minus 64. And we don't want that in the middle. We want the middle to be empty. And the only way that happens are if these are positive 8 and negative 8. Okay, here is also perfect square numbers. 4x squared is made up of 2x times 2x. And 121, if you don't know, is 11 times 11. And that's exactly what we want. We want to have one of each. Okay, this one, 10 is not a perfect square and 40 is not a perfect square, but do you notice there's a GCF? What do they have in common? They have a 10 in common. So we divide out a 10 first. Does that make sense? We divided a 10 from here and we divided a 10 from here. And now we can take this part, this is called a difference of a perfect square and a perfect square, because you can think of something that multiplies to get x squared as x times x. And 4 we know is 2 times 2, and we know we need one positive and one to be negative. So your final answer has this 10 in front, and that's like what we're going to work on our homework. All right, go ahead and practice these 5, and then check your answer. So to pause the video and try them on your own. Let's see how you guys did on these answers, and I just noticed I made a mistake on this one. So we would want both of these to be a 3, m minus 3, m minus 3. They are both minus because we want the outside inside to become negative 6. Another way you can write this answer, if you have the same exact thing twice in a row, you can write your answer as m minus 3 squared. So this is right, but this is also a way you might see that answer written. So see how these are the exact same? We could write these as 4h plus 5 squared. We cannot do that here because you have a plus and a minus. They're not exactly the same. Here they're not exactly the same. All right, this one we had to first divide out of 5. So you take out a 5 and you divide out of 5 and you get x squared, and 80 divided by 5 is 16. Now these are both perfect squares. So you can take x plus 4 and x minus 4, but you still want to write the 5 out here. If you guys can look for this worksheet, we're just going to do a few of these as practice together, And then this worksheet is going to end up being your assignment, and I'll show you how to get started on this worksheet as well. Okay, for this one, we're going to skip the first 6. If it has a star by it, that means we're going to have to factor out that GCF first. So 3 and 147 have a 3 in common. How many times does 3 go into 147? That would be, let me just do it right here. I have a calculator, so don't know where it is. Oh, 49. Okay, so we'd put 49 right there. All right, now this is what we want. It's a difference, it's a minus, and this is a perfect square, and 49 is a perfect square. So we do p times p to get our p squared, and then what multiplies to 49? 7 times 7, and make sure one's positive and one's negative. So this whole thing is your answer. Okay, this is written backwards, but it still is a perfect square minus a perfect square. So instead of starting with the r, you start with the 81. What times what is 81? 9 times 9. And then r times r. And here, because it's a minus, we want to have a positive and a negative. Okay. Let's go down to do this one, and this one, and this one. And we will be done with this paper. Okay, so 121 is 11 times 11, but notice it also has an m squared. So you just write 11m and 11m. 144 we know is 12 times 12, but it has a p squared. That's okay. You just want to write 12p and 12p, and then make sure you make one of them a negative and one a positive. Doesn't matter which order you put the negative and positive. This one has the star, meaning we first need to take out what they have in common. They have a 6 in common, leaving us with d squared minus 3. Now, 3 is not a perfect square. There's nothing that multiplies to 3. That's a pretty number, other than 3 times 1. And that's okay. If that happens, it's just you're done. You can't factor that any further. It's not 1.5. It's actually the square root of 3, which is this weird, like 1.7 number. So you just stop if this is not a perfect square. Okay, all right, this worksheet is going to be your homework. So here's how I hope this is going to happen, is I would like you guys to show your work down here, and I'm going to demonstrate that right now for you. And then when you're done, I do want to know what, write the answer in here for fun, what the answer is to the riddle. But instead of you just typing me back the answer to the riddle, I'd like you with your phone or with your computer, take a picture of this paper when you're finished, and then you can send it to me on Schoology, or you can email me a picture. So all you do is you just copy the picture on your phone, and then you just insert it on an email to me. Okay, so here's how this worksheet works. The question we're trying to answer is, why doesn't Giro bet on even numbers when playing roulette? Roulette's like a game at a casino with, it's got like all these different numbers, like 1, 2, 3, and then there's this little marble that bounces around. So why doesn't he bet on even numbers? Meaning he only likes to bet on odd numbers. And it's a silly joke, but when we solve these correctly, we're going to see what happens. This worksheet maybe looks really confusing, but I promise it's not. These 4 questions are going to have an answer that's one of these 8 choices. Kind of is like multiple choice, but there's more options. So we're going to do number 1 here together, and this is how I want you guys to show your work. I want you to number the problem you're on and write it down and solve it here. We're going to first start with the GCF. That's our first step, is try to do a GCF and then try to factor it further into double parentheses. Okay, so a 3 goes into 3 and into 75, leaving us with x squared minus 25. That's a perfect square, isn't it? 5 times 5 is 25. So 3, and then x times x, and we're doing a 5 and a negative 5. And then this is our answer, and we're going to look for that same answer up here. 3x plus 5, x minus 5. And see the letters HE, and this is for number 1. So what that means is you look for the ones right here, and you write HE. Okay, let's next do number 11 together, because that one probably looks a little scary, but it's really not that bad. So I'm going to write it down. Let's first see what these have in common. A 4 goes into all the numbers. A3B, A2B2, AB3. So we can take out a 4, an A, and a B. So what do you get if you have 4ab and you want to get to 4a3b? You need another a squared only. 4 times what would get us to 40? And it's negative 40, so negative 10. And we have an ab out, but we have an a squared b squared. So we need an extra ab. And finally, if you take 100 and divide out 4, we need 4 times 25 to get us back. We've taken out AB, and this is AB3, leaving us with B squared. Okay, so this 4AB, write it down again. And look, this is a perfect square, and so is this. We just have to be careful of our signs. So A times A goes here. Look at skip the 10 for right now. Look at the 25 is 5 times 5, and don't forget the B. And what signs do we need? If we want this to be positive, a positive times a positive works, but a negative times a negative is what we want. Because you see how this will result in negative 5 and negative 5, so negative 10 AB. So now we're going to look for this answer, and this is 11, so we're going to look in this section. And do you see how this is the same thing written twice? We could rewrite our answers 4AB, A minus 5B squared. And that, notice that's right here, AV. This is number 11. So we're going to write AV right here. Email me if you have questions, but good luck. I think this is a nice worksheet because you have options to help you. Okay?